Hi, this is Engage New York, Module 1, Topic C, Lesson 22B. We are going to be multiplying rational expressions. And if you're following along, here's some video notes. The first thing we're going to talk about is our exponent rules, and it's just a little bit of review from whatever previous math course that you've taken. And we have multiplying with like bases and we have dividing with like bases. So what you're going to do right now is in your notes, you're going to pause this video, you're going to write down multiplying like bases, and you need to write down this example, and you need to write down that you are going to add the exponents versus dividing like bases. If you notice, like base, and you subtract the exponents. So you need to subtract exponents. Make sure this is in your notes. We're going to be using it, and it's going to be a prerequisite skill that you bring into the classroom ready to use. Okay. Now that you have in your notes, you have written down your exponent rules. Let's do a couple examples just to review. Let's see. Okay, so sometimes you're going to come across something that looks like this, and that is a negative exponent. Negative exponent. And if in the shortest way to describe a negative exponent, if it's upstairs, you're bringing it downstairs. So if the negative exponent is in the numerator, then you're bringing the entire term, or whatever it's attached to, the factor that it's attached to the denominator. If the negative exponent is already in the denominator, say you have x to the negative n, and you need to simplify this, then this negative in the exponent should cue you to move it to the numerator if it's in the denominator. So then if you move it to the numerator, then you have something that looks like this, x to the positive n. So this is an equivalent statement, and then separately, this is an equivalent statement. And if you're wondering if you can't ever remember why it is, as a side note, I want you to think about, oh, lovely. I want you to think about x to the 0 power, what 1 is. 1 is x to the 0 power. 1 is anything to the 0 power. But in this case, let's use x to the 0 power over x to the n power. So x to the 0 power would be our 1 right here, and then x to the n is our x to the n. Using our divide with like bases, we're going to subtract exponents. Because they have the same base, x, you can subtract the exponents, which means now you're left with 0 minus n, or negative n. So if you're wondering why it moves to the numerator from the denominator, or to the denominator from the numerator, you can always think of it as a 0 power, and then you're subtracting using your exponent rules. Okay, so as another example, if you have x to the negative 2 power, that means if this is x over 1, then this x term moves to the denominator. So now you have 1 over x squared. When you move the factor to the denominator, then the negative sign goes away. If you have something like this, xy to the negative 2, if you look closely here, this negative 2 is attached. The closest thing to this negative 2 is the parentheses. That means everything in the parentheses has got to move down to the denominator. So 1 over xy squared. So the negative sign is gone, but the 2 is still there. Okay. And then, but if you have this, xy to the negative 2, this negative 2 is not attached to any parentheses. That means this negative 2 is only acting on the y. That means the x stays in the numerator and the y goes to the denominator, y over x squared. Okay. If you have any questions about this, write them down in your notes, annotate your notes in a way. If you need another example, that's something you can also add to your notes, or you can search negative exponents as well. Okay. Let's go on to some examples about multiplying rational expressions. And the only difference between these rational expressions and what we've been doing is that maybe you have to factor once more. So the rules are the same. The rules are the same, that you should factor first. Factor. So sometimes this is GCF, sometimes this is a trinomial, sometimes maybe this is factor by grouping, but the first step is to try to factor each factor some more, because then we are going to multiply across. If it says multiply, we're going to multiply across, and then we're going to simplify to lowest terms. There you go. Okay, so let's try this out. The instructions are find the product and reduce to lowest terms. So we have to do two things. We have to multiply, and then we have to reduce. Excuse me. Okay, let's factor first. And I'm looking at this numerator, and it says 4x plus 2. So its greatest common factor is 2, and I'm left with 2x plus 1. And then I'm going to draw a bar, and then my 3x is going to stay 3x. Okay. In my numerator on my second term here, I'm going to factor out a 3. And I'm thinking ahead because I see a 3x in my denominator. And it doesn't hurt if I factor it and it doesn't need to be crossed out, then it just kind of gets put back together. So I'm just playing it safe and factoring out a 3 and a 3x. And then in my denominator, I have left over just a 2x plus 1. Okay. Now, to simplify this, I'm going to multiply across. Now I'm going to draw a big bar, and I'm going to put all my factors together. I'm just going to copy down my factors. 2x plus 1, and then I'm going to reorganize. 3x over 3x and 2x plus 1. Instead of me like crossing here and maybe crossing here and then losing track of my factors, the best practice that you can do right now to improve your skills is to stay organized, and you're going to rewrite this expression once more. And you are going to rewrite it so that all of the factors that you want to simplify using the property of 1, you're going to line up. So I have 2x over here, 2x plus 1, and I'm going to write 2x plus 1 right beneath it. Then I'm going to write 3x, and then I'm going to write my 3x right beneath it. Then all my other factors that I still need to write, 2 and 3, I'm just going to write on the other side because it makes it a lot easier to do this. A 1 and a 1, and I'm left with 2 times 3, which is just 6. If you have any caution signs to add in, stars or question marks, go ahead and annotate that now, and then I will meet you at the next example. This example. Okay, so we're still going to do the same steps. What I'm going to do is I'm going to take this. It's going to come with me, hopefully. Okay, we are going to continue to factor and then multiply across and then simplify. So I'm going to factor this out first. I'm looking at the numerator and I'm like, I don't know where this is going, but I think I'm just going to try to factor first. So I have big parentheses, and I'm going to do 2 and x plus 3. Draw a bar. And then this denominator here, I'm going to use my mental math for. If I needed to use my scratch paper, I would do so on the right side of the screen, and I would do a combine and multiply t-chart and then reverse box method. But at this point, I want you to use your mental math and break up the two binomials so that you have x plus 3 and x minus 2. Great. And then we have another set of parentheses, and inside, let's take a look at our numerator. Our numerator is going to be x squared minus 4, and you should recognize this is difference of squares, and you should have x minus 2 and x plus 2 in your mental math factoring arsenal. And then in the denominator, you're going to have your 2x still. So now it's the time where we're going to multiply across. And when we multiply across, I'm just going to squish all the factors together, and then I'm going to reorganize. So I'm going to squish all my factors together. I have 2, x plus 3, x minus 2, x plus 2, then I have x plus 3, x minus 2, and 2x. So what I have now is I'm going to rewrite my factors, except I'm going to line them up. Anything that I think I can cancel out, I'm going to do my very best to line up and organize. So let's start with this x minus 3. So I have x plus 3, and then I'm going to line it up with the other x plus 3. Now I have x minus 2, minus 2, over x minus 2. What else do I have up here? I have an x plus 2, and then I have a 2, and then I have a 2x. So if you notice, I didn't factor this factor more, but I'm going to do that in my next step. So I'm going to draw big 1s through these two factors using my property of 1 because I can. And now I have left x plus 2 and 2, and I'm going to break up these two factors. So I'm going to have a 2 underneath my other 2, and I'm going to have an x left over. And yes, I can switch my factors around because they are factors. There's no plus sign in between them. There's no minus sign in between. I'm just breaking it up. It is 2 times x, which leads me again to be able to cancel out these 2's, and I have x plus 2 over x. At this point, if you have any questions, if you need to go back to the video and pause, do so now, and then we're going to move on to our last example. So in our last example, our directions are to find the following product and reduce to lowest terms. So again, we're going to find the product, and then we're going to reduce to lowest terms. So I'm just highlighting what I think are important words that I should take from this. I'm also going to bring our little steps with us. Let's see if I can bring this with. Okay, so back to this example. I'm looking at this and I'm scanning this, and a lot of things are going on. So I have a 4, and I've got a -2, I have 2 variables, I have an n and an m. So I have a lot of things going on, but I'm going to use my same 3 steps. I'm going to factor, I'm going to multiply across, and I'm going to simplify. Now, the other thing I want you to consider is that we also have our order of operations. So we have PEMDAS. And in PEMDAS, we have to deal with the parentheses first. That'll be our factoring part. Our exponents, I already see an exponent. Then we get to multiply across. And we may not even meet the last 3. So let's factor first. Let's just use what we know, our 3 steps, and factor first. So inside these parentheses, I'm going to factor out a 4 and get n minus 3. I'm going to get 3, and I'm factoring out a 3, and I have m plus 2. Be careful, these are different variables. And then I'm going to factor out the insides of this term. And using my good mental math, I'm going to do n minus 3 and n plus 1. And then in the denominator, I'm going to get m plus 2 and m plus 2. Okay. Now, we factored, we dealt with the parentheses, now let's deal with the exponents. So let's deal with the negative part of the exponent first. So to go from, you can take away this negative sign if you promise to switch the numerator and denominator. So I'm going to switch the numerator and the denominator. Okay, and then at this point, we're just copying down the rest here. N minus 3, n plus 1 over n plus 2, n plus 2. Okay, now how do we deal with this exponent? For those of you who can't remember, like, do I add the exponents? Do I subtract them? Do I multiply the exponents? Etc., etc. What you can do is this 2 just means you're going to take the whole parentheses times itself again. In any case where it's a square, you're going to take the quantity and times it by itself. So if you can't remember if you should multiply or add the exponents, what you can do, definitely, is you can rewrite this whole factor twice. So let's do that for kicks. Let me draw on some bars here. 3 over n plus 2, 3 over n plus 2. This is using your prior knowledge. You know that something squared is just the same thing twice. Okay. So now we took care of that too, and we're going to copy down the rest of this factor over here. Okay. Now, part of our rules, we factored, we multiplied across. Did we multiply across yet? We're going to do that. So let's multiply across and simplify. Oh my goodness, I forgot all of my equal signs. Can't do that. Okay. So let's make an equivalent statement. Let's draw a big fraction bar. And let's just rewrite all of our factors. I'm just going to rewrite all of them. I'll keep my colors. Okay. 3, n plus 2, 3, n plus 2, n minus 3, n plus 1, over 4, n minus 3, 4, n minus 3, n plus 2, n plus 2. If you're one of those people that's wondering, when do I keep parentheses signs? When can I take them off? If you want to play it safe when you multiply rational expressions, you can have more parentheses. And if you really want to get into specifics about like when to use parentheses and brackets, etc., those are questions you can also bring to class or come to office hours and ask your teacher. Okay, let's rewrite all of these factors so that we can cancel out the ones. So I'm going to draw a big fraction bar again, and I'm going to move all of my numbers to the front or to the left, because I want to see what I can cancel out from there. Otherwise, I have an n plus 2, another n plus 2, an n minus 3, and an n plus 1. Let's see, 4, and then another 4. I have an n plus 2 I can line up. I have another n plus 2 that I could also line up. And then I have an n minus 3 that I can line up right underneath the numerator, and an n minus 3 again. So with this, I can't cancel this out, but I can cancel out these factors, and these factors, and I can be left with 3 and 3 is 9, n plus 1, and 4 and 4 is 16. And I have n minus 3 left over. Let's see, all the n's are lined up. Great. Okay, at this point, you should write your summary down here, summary of your notes. Make sure you bullet point the most important things in this video and check if you have a problem set to do. And you should write down any questions that you have and then highlight the biggest ideas that you have for tomorrow. Come to class prepared. Okay, that's it. Bye.